Hi, my name's Luke McKinney. I'm Prep 101's Physics 1401 instructor, and this video is about the equations of motion. What to do when you've got a constant acceleration. These get a lot of problems on their own, and they can fit together with force problems.
The equations of motion are a beautiful set of equations because they give us a bunch of marks on the exam every year. They get questions to themselves, and they're very often a two-part question with forces connected by the acceleration. So how do we know we have an equations of motion question? Very handily, the key point is the idea of constant acceleration. If you have a constant acceleration, and that can include zero, then it's equations of motion. If you don't have a constant acceleration, then that'll be a conservation of energy problem usually, and that's later in the course. So how do you know you have a constant acceleration problem? Well, oftentimes you'll just be told directly in the text of the problem that things are moving with constant acceleration. Another type of problem is if something's falling in free fall. We know its acceleration is the acceleration due to gravity, 9.8 meters per second squared down. Or you might have some arrangement where you have blocks on a slope with friction and tension and all of that. We'll see that in later primers. But the idea is you do a bunch of force problems which give you the acceleration. And then that's a constant acceleration, because even as things move around, the whole arrangement of the situation isn't changing. So once you've got a constant acceleration, you can go straight into the equations of motion. So let's have a look at those now. The first equation of motion is the new velocity is the old velocity plus the acceleration times time. This is true in X, in Y, and Z. You can put on little subscripts if you like, but the key point there is you'll notice is that I said the words. I didn't say V equals V0 plus AT, because that's useless to me. Any questions are going to be talking about cars stopping and starting, or balls accelerating or slowing down. So saying V0 on that doesn't help. So you say the words. The new velocity is the old velocity plus the acceleration times time. The next one is the change in position is the old velocity times time plus a half the acceleration time squared. And you always remember the change in position is the new position minus the old position. And then the new velocity squared is the old velocity squared plus twice the acceleration times the change in position. And there's the little novelty one, less useful, but it's on the course, so we mention it. The change in position is a half the old velocity plus the new velocity times time. And that only works because we have constant acceleration, because we can see this term here is just an average velocity. Now, how do we know which of these to use? Well, you see there's some nice ways to fill it in. The first is you can just hammer at them. The problem will have given you enough numbers to fill in one of the equations. Only have one value left over, and that's the one you do. If you want to look at things a little quicker, you can see this equation here has no time term. So you can skip straight to that in problems where they don't mention time. For example, if they say, how long does it take for a truck to stop? It'll be one or both of these. But if they say the truck skids to a stop in 100 meters, when they mention a distance instead of time, it'll be that third equation there, which is the useful one. Now, when we're dealing with equations of motion, as we saw, we've got a bunch of equations. We want to plug in numbers, but a lot of the numbers will be given to you as words rather than letters. For example, if something starts from rest, we immediately translate that as the old velocity is 0. Likewise, if something stops, that means the new velocity is 0. A special case is if something is dropped by something else, then it starts with the velocity of that object. For example, if I'm just standing here and I drop an apple, well, my velocity was 0. So the apple starts with a velocity of 0. But if a helicopter was flying along, you can see my amazing art there, with a velocity of 20 meters per second, and it drops a crate of supplies, then those supplies will also start with a velocity of 20 meters per second to the right, which is fun. Another value that very often turns up in these problems is g, the acceleration due to gravity near the surface of the Earth. If I drop this apple, I know it'll fall down, and the acceleration will be the acceleration due to gravity, 9.8 meters per second squared down. And that's the free fall acceleration. Now remember, that is near the surface of the Earth. If you're near the moon or a Jupiter or something else, there will be a different value of g, which you would have to be either given in order to calculate the problem, or it would be the only unknown value. They might have given you everything else, and then you can work out g in this situation.
Well, I hope that video was useful. What's even more useful is more videos, and you'll find plenty more in the playlists here. But even more useful than that would be a live session with lots of focused practice, the ability to answer your questions, and then doing lots of exam-style practice with focused example problems and full solutions. Because that's what we do at Prep 101. So make sure to join our Prep 101 Study Hub Facebook page, where you'll get details about all the sessions, some of them are even free sometimes, and other resources that'll help you to do better on your exam.